integral, by definition, is a Riemann sum. If you have a continuous function and you divide the interval from a to b into n subintervals of equal width, delta x is going to be b minus a over n. I have a picture on my next page. Okay, guys? Trevor? Not going to last long. I don't know why that's coming up with the eraser. So if I divide this, I want to find out how big each of those little delta x's are. Then I take b minus a and divide it into the number of rectangles. So, and generally we want to go to infinity, but sometimes in the exam, they make it like 50. It just means 50 rectangles. So that's the number of rectangles. Tried a different approach this year. And I'll show you problems tomorrow. So you can, because they didn't get it when I just say n goes to infinity. N could be any number. If n is 100, you divide it into 100 rectangles. It has nothing to do with the A or the B. Nothing at all, just how many rectangles you have. Okay? And we are going to choose sample points in the interval. This is kind of interesting. By the way, you don't have to have all the same size on the delta x's. You could have them all different sizes. The only condition is the biggest one of these subintervals has to go to 0. Now think for a second. If the biggest width here goes to 0, what's true about all the other widths? Yeah, they go to 0 as well. The area, they end up looking at little slices like this. Very tiny area. But you're going to add up an infinite number of them, so you're going to fill it. Does that make sense? That's how the calculator does the definite integrals, actually. It does rectangles. If you have my program, you have the ability to put in like 8 rectangles. You know, or whatever you want it to do. Now, when I choose my sample points here, I don't have to pick the left side or the right side. I can mix them all up. They don't have to be the same. So that's x of I. That's your sample point. In other words, when I use my rectangle right here, that's going to give me the y value. That x coordinate will lead me to the y value that gives me the height of my rectangle. So that's kind of cool about this. For a Riemann sum, the widths of the intervals can all be different. I like to have them all the same because then it's easier to do the arithmetic. Okay? Phones, put away. It's just easier. But they don't have to be. So, or really should have a delta x sub I here. Now, Riemann said, I'm going to add up the areas of all the rectangles. This is the height. This is the base. And you guys know sigma. It just means find the height and base of all these rectangles. So I'm going to add up the area of each one of these until it gets filled up. But he didn't like writing this all the time. You don't like writing it, do you? No. So he made up a symbol. And he made up this little integral symbol. And I think it looks like an S. And the German word, because Riemann was German, the German word for adding up is sum. Summa, like summa cum laude, with, sum. Anyways, S-U-M-M-E. Actually, I don't know if that's close. I know that song. Okay, that's all it's saying is find the base. Dx is the base. And this is the height. Find them for each one of the little rectangles and add them all the way up from A to B. That's called a Riemann sum. You also know the fundamental theorem, which is a theorem you can prove. And maybe we will. Okay, so it's the sum of the areas of the rectangles. I like the way this textbook describes it. Okay, Bjorn, put your computer away. It's the sum of the areas of the rectangles above the x-axis and the negatives of the areas of the rectangles that lie below the x-axis. So if it looks like this, even though this area here is a positive number, the integral is a negative number. Okay, Eric, does that make sense? This is a signed area. So if your function drops below the x-axis, that number will be negative. So what if I take the sine function between 0 and 2 pi? That area's integral is 0. That's your displacement versus your distance. Okay, so this gives you a displacement. If you want the total area, you're going to have to absolute value it. Okay, so I did that. That's on the other one. Now let's look at what the x values would be, just so we're kind of in the same place. And then we'll do the examples. Some of you are getting your calculators out to integrate it, but we're not integrating that. We're just rewriting it. Now, what would your x-coordinate be? We did this yesterday. Here's delta x. And now, if I find x1, and I've got a kind of a mess here, but if this is my first x-coordinate right there, how far is it from the axis? What's this distance? A. And then you're going to go, how many of those delta x's? 1. Because you're going to x1. So it's A, because you got to get over to this point, the A value, and then you have to add in that little width, plus 1 delta x. So what's x2? You have to go over here. You start here. How many of these intervals are we going to go over now? For the second one, 2. What's x3? How many intervals are we going to go over for this one? 3, but you have to add in the A. That's what's different. If you don't see anything added, then A is 0. A plus 3 delta x. So what's x sub I? I will give you the AP problems tomorrow. I got to find them. Because it's going to be on the exam. Because if I didn't have calculus, I'd have to find the area of all the rectangles. I need this first coordinate, because what's the height? It's f of x sub 1. And that's my x value. So if f of x is equal to x squared, but on the exam they're going to give it to you, you have to recognize what it is. Then you do the calculus. So what's f of x sub 1? It's a plus 1 delta x squared. That doesn't look like an x coordinate to me. But that is what it is. And we could do some by hand if you'd like. You wish that you didn't. They're painful. That's right. And you have to be able to recognize it on the exam and say, oh, I have calculus. I'm not going to do these limits.
So I recognize it now.
Well, I don't know that you will. Wait till the class opener mouth. This is plus I delta x. So that, when you do your Riemann sum, want to put it all together, it's pretty ugly. Okay, Eric? Yeah, it is. Because you're going to add the delta x times f. Whoops. These are good questions. Delta x times f of x1 plus, you're going to do delta x base f of x2, right? Plus delta x f of x3, and I don't have enough space, plus delta x, and there's some ones in between. I want the I one to represent any of them. It could be tenths, could be hundredths, could be millions. It's a series. And the last one is delta x. And by the way, all these delta x's could be different. I'm going to make them the same so I can factor it out. Then this is f of x of n. So I have n rectangles right now, so it would be 50 if I chose 50. So you actually get a little formula if you wanted to do it. Well, let's factor out delta x. That is f of x of 1 plus f of x of 2 plus f of x of 3 plus, okay guys, Alex, f of x sub I. That just represents anything between 1 and n. F of x sub n. But you know what? That's painful to write all that out, isn't it? So we're going to do this. It's delta x. Let's put the summation over here. And it's f of x sub I. Where my counter is I equals 1 to n. Remember sigma? And then what we're going to do, we're going to move that, and then we're going to take the limit and let n go to infinity. What your calculator does, I don't know how many rectangles they put in there. Not that many, maybe 50. When you play with the Riemann sum program, that's Riemann with 2 n's on your calculator, then you'll see, keep increasing the number of rectangles until it does look like it's filled up. Because the calculator doesn't know calculus, but it knows how to add up the areas of the rectangles. It's exactly what it's doing. That is what the calculator is doing when you do the definite integral. Yes. If you don't have a definite integral, you can't use your calculator. You have to have a CAS. Sorry. I bought the wrong version of the Inspire. I'm going to try and get it switched so I get the CAS. was so anxious to get it, I just clicked on the first thing I saw. That was a mistake. Okay. The point is you're going to have to recognize these. Now, that was hard work, but it's not so hard here. Write that as a Riemann sum. Okay, Zach? How do you write that as a Riemann sum? It's the limit as n goes to infinity. Well, and for this, we're not going to go, well, we could find out what x of I is, but it's f of x of I delta x. So it's the limit as n goes to infinity. All the book is asking you to do is this. I equals 1 to n, and it's 1 over 2 x of I minus 7, and it's a delta x. I think that's all they're asking you to do, if I remember. But on the exam, they might be more complicated than that. How would you find this delta x? In this particular case, what's delta x equal to? It's b minus a divided by n. So it's going to be 3 minus 1 divided by n, because that's the number of rectangles. So I'm going to take the full width of 2 and divide it into n equal parts. Then what's x of I? Remember, that was your starting value plus I, because it's where you are in your interval, times delta x. And that's the thing you might have to recognize. So what's my a value here? Where you're starting at 1. Does that, if I say the interval is 2, does that get me up to 3? If I start at 1, and the width of the interval is 2, does that get me to 3? Yeah. So it's plus I and delta x is 2 over n. I don't think that they're asking you to do that. I'd have to go look at the answers. No, n is n. What? Oh, yeah, well, it asks to do that, too. You can do it for 4. That's right. It's not quite the same here, because I looked at that. So x of I is the where you start on this function. That's your first x coordinates. You got to go over to the 1. You're not starting at 0. And then you go over 1 of the little delta x. So x of 1 is equal to 1 plus 1 times delta x. What's x of 2? It's 1 plus 2 delta x. It's just a little formula. You could do 4. I don't want to. I mean, you can find that if you want. If not, let's use our Riemann sum program, which I haven't still gotten on my computer yet. Did anybody want to try that with 4? You got the Riemann sum program. Let's do that. So n equals 4. So you are going to type this 1 over 2x minus 7 in for the function, because it'll say function. Everybody has the program? Be careful with your order of operations. So try that. Do you guys have the program over here? Do you have your calculator? I have to borrow a calculator. It's Riemann with 2 n's. Yes. It's like an app. You should have them all, because I gave all of them to you. So if there's one I could borrow for a second. Or do you have it over here, you guys? Partitions. How many rectangles do you want? Partitions is how many rectangles? So we're going to do 4. Does anybody here have it? Do you know how to transfer it? Okay. Why is this not fitting? There we go. Oh, then you didn't get it all. Maybe you didn't have enough space. Okay, so we can get it for you. We can just do 1. Okay, you got to go into second link, and you're going to receive. You must be receiving before I can hit transmit. So, no, just omit it. 3. Because you have all those. You must have some of them. Okay, let's get you going. I got another link. Did anybody try it? I don't know what the answer is. Oh. Ooh. Eric. Oh, I'll do this in a second. kind do you have? You have an 83. Well, they'll be done. They'll be done in a second. They should be done. You done? Yes. Yeah, you don't want all that. Just go 4 or whatever it is. What's an option on your thing?
There's no option.
Well, there was. Okay. It's okay. I have to use this link. I've got a regular link that'll work. We'll see. There you go. You guys know how to do it now? Did anybody get an answer? Can't get negative. Try Riemann. 4 rectangles. Which one do you want to do, right, midpoint, or left? Says what? Okay, midpoint's the best. Oh, yeah, it is underneath there. Okay. So what did you get? Negative what? Eric, what did you get? Negative what? That is what you got? I can bring up my calculator and find it exactly. But you guys could too. Do you guys remember how to put that into your calculator? Yeah, do you know how to remember how to do it? Let's review it. I want to make sure you remember how to do that. It's okay to say you don't remember. Doing that upside down is not easy. We're almost done. Because this is not, well, I don't know, I got 2 days on it for some reason. Okay, I'm going to put the function in y equals. Because I like it there. Okay, you guys, there's 2 ways to do this. If I want to see the rectangles, kind of, at least it's shading, I'll go to the graph. So I'm going to zoom it 4. And I want to integrate from 1 to 3. Well, that's interesting. Oh, no, that's okay. I'm okay. And so you go second, calculate, and you do integral 7. And it says, where do you want to start? I want to start at 1. Press enter. And I want to go to 3. Press enter. There it is. Should have gotten negative 0.8047. So that's the actual answer, and it shades it. Now, do you guys remember that?
Well, that's because you only have 4 parts. If you had more than 4 parts.
That's right. But you can control that because you have the app to do it. You have to go through the menu. On the bottom of it says quit. Not all of them are that way. Mm. There. Okay. Let's do the other one. Okay, I'm going to clear this. And if you have the new operating system, you don't have to do this long way, but it's math, and it's 9. Now, mine's in pretty print. Oh, no, it's not. I put it in Y1. And then I put a comma in, if I can find it. Oops. Comma, X, comma, 1, comma, 3. Can you integrate over that vertical asymptote? There it is. Okay, guys, let's go. Keep going. We just have a few more problems to do. Okay, Eric? All you have to do is write that as an integral. That's all there is. You're just going to integrate, and it's x squared minus the sine of x. No, you're not integrating it. It says write it as an integral from 0 to 2 pi. That's all you have to do. You don't do it. You just write it. Hey, do you guys figure this out? John is just asking you to write it as an integral. We'll talk about how to do that, but most of you probably remember how to do that. But this is all you have to do for this assignment. It says write as an integral, just write it that way. And you have tomorrow to work on it as well. Okay, this is problem 21. And it's hard, I can't see it on here. You can open your book and look at it. Okay, so all this is asking for is the signed area under the curve from 0 to 2. Could you count squares? Sure. I got 1, 2, 3. 3 whole ones. That looks like 4 to me. How about 0 to 5? It's 4 plus that column, which is... Okay, now be careful. Sometimes, you guys, this is a decimal point, 0.2. So read it carefully. 5 to 7. There's 5. Oh, wait, I did this wrong. Okay, 0 to 5 was what? It's 0 to 2 plus then 2 to 5. So that's 4. And 2 to 5 is all of this. So it's 1, 2, 3, 4. You probably have to do a triangle. So that's 3 plus 1/2. The base of this triangle is 2. And the height is 3. I want to get it right. So it's 7 plus 3. So that should be 10. Did I do that right? That's all it's asking for. What about 5 to 7? Now, why is it negative? Because the y value is negative. So order makes a difference. So to do this one, it's yes. Because if you go left to right, that delta x is positive. If you go right to left, delta x is negative. So it's 1/2. 5 to 7 is base is 2. And the height is what? Negative 3. So the answer is negative 3. That's the way to remember it. What about 0 to 9? Well, we can do, how about this? We could do 0 to 5 plus 5 to 7 plus 7 to 9. Is that going to give me 0 to 9? Those are the properties. I'm just using them. Okay, 0 to 5 was 10, right? That was 10. 5 to 7 is a minus 3. Okay, guys? And what's 7 to 9? Oh, what shape is that? That's a trapezoid. Do you remember? Okay, you could take the 4 rectangles. If they ask for trapezoidal rule, you're going to have to be careful. So it's 4, but it's negative, right? Plus, and it's 1/2 base, which is 2, and the height of this little triangle is 1. So it's 7 minus 5. I don't know, is it right? Don't always trust me on these things, is it right? You have from 0 to 5, which was 10. Then you have to subtract off this little bit here, which is minus 3. And let's do a trapezoidal rule. It's 1/2 the height, sum of the bases, 2 plus 3. So that's 5. So it's going to be 10 minus 3 minus 5. It's 2. Questions? Okay, how are you going to do these guys? Can I move that? B is easier. How are we going to do that one? Because you can distribute the integral sign, find the area under 1, plus find the area under y equals 2x. Now, this is what the students got wrong in the AV class. They thought this area was 1. Graph it. It's going to be y equals 1 from 1 to 3. So this base is 2, and the height is 1. What about this one? If I graph y equals 2x, you got to be careful. You're not starting at 0. This is, but I'm going to go from 1 to 3. So I want this area. Remember the formula? For trapezoids, it's 1/2. I did it quickly. Times the height, times the sum of the bases. I'm not going to count squares now. What's the height here? Ori? This is the height. It's not sitting on the base. It's 2. Then I need this base. That's the y value when x is 1. So it's 2 times 1, which is 2, plus, and 3 times 2, which is 6. Not 12, it's what? 2 plus 6 is 8. So this is 2 plus 8. Gives you a final answer of 10. Right. It's easy to go from 0 to 3 by accident. Does happen. What is this graph? Okay, if you don't know, put it on your calculator. It's half of a circle. Do you want to know why it is? No, because it's this. Y equals 9 minus x squared. How would I get rid of the squaring, Ori? Eric? I would square both sides. No, I'm squaring, not square rooting. When you square root, you're going to get plus and minus, not when you square. So this is 9 minus x squared, because when you square root, you get an absolute value. That's what gives you the plus and minus. The radicals are never negative. And then I'm going to add x squared to both sides. And now do you recognize this? That's the equation of a circle with a center at 0, 0, and a radius of 3. So I only have the top half of the circle. Because if I have the bottom half, guys, I have the bottom half, I don't have a function. So it's just half a circle. So it's 1/2 pi r squared. So I think Alex told me this. Okay? One last one to challenge you. What's not that bad? Is that easier? Is that the same one I have on there? Yeah, 3 to 8. You know, if I couldn't see it, I'm going to draw a picture. Here's 3. Here's 8. That's the first one. I want to subtract off the integral from 3 to 5. I want to subtract that off. So what am I left with? The integral from 5 to 8. Okay, these are all examples of problems in your textbook. You were right. So if you look at the assignment sheet, I have to run back to my office and get more assignment sheets. I have them. I know we're short. It's a 2-day assignment, if I recall. So tomorrow I'll bring in the AP questions that have to do with this. Yeah, they're hard. Do you have any questions on 5-1? Use your calculator.